Question number 4 is a parametric equation question where I've been given the position vector. Find the maximum speed. So that's going to be F max of the magnitude of R dot. So R dot will be the derivative of this. Draw on the calculator to get that answer. Derivative of this, put in the calculator to get that answer, square them, add them together. And then I've got F max, which gave me 100 pi on 3. And I double checked it because that value is 104.7191. And then I graphed my square root and made sure the maximum was that value, and it was. Okay, use RA to show that the Cartesian equation gives me this. Okay, so I'm going to make x equal this, and then rearrange to get the sign by itself and then square it. Make y equal this, rearrange it to get cos by itself and then square it, because you know that sine squared plus cos squared is equal to 1. So what I've done is, keeping an eye on what you've got to try and solve, I've got my sine of t is this, my sine is this, and my sine squared will be that. My y is going to equal this side here, so put them together and rearrange to get exactly what you're asked to find. So we have an ellipse that is centered at 450 and 400, and it goes 150 either side to the left and 200 either side to the right. So on the next page, when you're asked to draw this thing, then I can draw this ellipse comfortably by putting the center at 450 and 400, 150 either side, 200 either side. I can also double check it on my calculator by putting it into parametric equations, and when I graph it, I might go zoom auto. Oh, I might change my values to exactly what the values here are. So my x's go from 0 to 1400, and my y's go from 0 to 800. 0 to 800. And there's the drawing. It didn't draw at all because if I go into my window, I need to increase my t to go more than 2 pi. So I might go to 4 pi. And now when it draws it all. Notice that when you draw it, that it starts drawing it there. It starts drawing it down there on the bottom because you were asked to label where it starts. So I've got my starting point and the direction of motion. Okay, so that's that graph. Part D, determine whether the drone will make contact with the aeroplane. Where is the drone? These pages are out of order. That's C, and here is my drone. Okay, so my drone follows this particular rule. I've turned that into the x equals 30t, solve for t, substitute into the second one the value of x on your calculator, make sure you're able to draw it, and then you end up with this rule, and then you can add that to this particular diagram. Indeed, determine whether it will make contact with the aeroplane. Okay, so I'm going to make the x components of the drone and the aeroplane equal, solve for t, and I get 12.84. And when I make the y components of the drone and aeroplane equal, they're equal on all these occasions, and none of them are the same time that the x's are equal, therefore no collision. And that's the question.